Morning, ma'am. So first, before I enter into the topic, first of all, the subject code and subject name. Then we move on to the topics. Our subject code MA8451 PRP, probability and random process. Here we are going to see for Unit 5. Today we are going to this lecture for Unit 5, linear system with random inputs. Linear system with random inputs, that is the topic. So like we can already study for Unit 4, correlation and regression, correlation and spectral densities. The same continuity for here. One input function is given x of t and the output function y of t. Here we can go for find the autocorrelation function, normally we can say ACF, autocorrelation function, cross correlation function for the input and output of the system. That is the basic idea we are going to see for here. So before we enter into the topics, what we are going to see in this lecture, the main things. First of all, what is the system? What is system? And the second one, what is a linear system? Linear system. And the third one, what is a time invariant system? That is linear time invariant system. Normally we can say LTI system, linear time invariant system, LTI system. And fourth one, and what do you mean by causal system? CAU, causal system. And fifth one, what is a stable system? Stable system. And then next one, the relationship between the input and output functions. So these are the things we are going to see today. And what do you mean by system? Already we can know for what is already we can study for computer science function. Normally C++ or like C, whatever you can study. What do you mean by function? Normally we can written as y is equal to some f of x. F is a function of x. Some other relationship between the x and y. Normally we can call it as x as the input, y as the output. The same one here we can include some time, that is we can go for system. So a system is nothing but y of t equal to some function of x of t. That is a system. That is a relationship between the input function x of t and the output function y of t. Here normally you can indicate in the term f is a function. Instead of f, some of the book they can write L. Because of we can using linear system, that's why we can apply for L. So F or L is nothing but operator. What is the responsibilities here doing that f of x of t? So that is the f or L. It's a relationship between the input function x of t and the output function y of t. That is called system. So now this y of t, either you can write it is an output or the another name response. Normally I can talk here what is your response. Normally that is we can expect it the output. So response. So either it is output or response we can say. That is system. Then come back to what do you mean by linear system? You know the system is nothing but input and output, how they are related. What do you mean by linear system? Already we can study the many of the thing mathematically. Linear combination we can study. So here the linear system, the sum of the input is some addition of the input. The output is separately for the systems. So now we can write the system y of c1 x1 of t plus c2 x2 of t. I would like to take only the two terms. Y of c1 of x of t plus x2 of t. It is equal to, that is the sum of the inputs is equal to c1 into y1 of x1 of t plus c2 into y2 of x2 of t. So that is the linear system. If this condition is satisfied, we can say the given function or the given system is a linear system. So here the y1 of x1 of t is a corresponding input x1 of t, and y2 of x2 of t is the corresponding input x2 of t. This is we are going to see for here. I will give some examples how to identify. I will give some examples for the linear system. Let's take one example. Y of t equal to some alpha into x of t. I like to take this. Check whether it is a linear or not. You can go apply this formula. Some that is y of the input function is this is called as. I like to go for c1 x1 of t plus c2 x2 of t. That is the input function that is equal to. So the function y of t that is equal to alpha into x of t, where alpha is a scalar. Alpha is a scalar. So alpha into x of t I like to take this. So here I can take it for here. So whatever the input, this is you can simply write y of t or you can write y of x of t. Both are same meaning. What is the input function x of t? Can just multiply a scalar alpha. So I like to alpha into the entire things is my input. C1 x1 of t plus C2 x2 of t. I like to my alpha is a scalar. I like to try to multiply inside. So C1 alpha into x1 of t plus C2 alpha into C2. Okay, C2 alpha into x2 of t. That is equal to alpha into x1 of t. I like to take the C1 y1 of t. Alpha into x2 of t, C2 into y2 of t. So therefore the system is linear. So it satisfied C1 into y of t, C2 into some y2 of t. So the given system is linear. So sometimes they can asking for define linear system. Give an example. This is the best example for here. Even I will give one more example. Y of t that is equal to t into x of t. Y of t equal to t into x of t. That is also is a linear system. Suppose give an example which is not linear. Y of t equal to x of, let's take it as some x square of t. Clearly the system is not linear. Even you can substitute for here y of c1 x1 of t plus c2 into x2 of t, that is equal to, here the terms, input, whatever the input you can square, that is output. That is a c1 x1 of t plus c2 x2 of t to the whole square. So we know the formula, expand a plus b the whole square here. So ultimately I can expand c1 square x1 square of t plus c2 square x2 square of t, a square plus b square plus 2ab. So 2 times c1 c2 x1 of t into x2 of t. So clearly which cannot be written as c1 y1 of t plus c2 into y2 of t, because here c1 square and 2 times that value. So but this is not possible for here. So the system is example of it is not linear system. So sometimes they are asking what is a linear system. Give an example whether it is linear or non-linear case. So next one, what is a time invariant system? Linear, already you can study the term here. In addition, what do you mean by time invariant? For example, what is the shift? Sometimes system y of x of t equal to or some function of x of t. Y of t equal to some function of x of t, normally we can say it is a system. So what is the shift in the input? It is equal to the same shift in the output. That is called time invariant system. How much shift? Sometimes you can push some other things. The function do not change the relationship after change some time interval. So that is here y of t plus h. That is equal to some f of x of t plus h. That is called invariant system, time invariant system. In the existing time, I would like to change some shift. I would like to push or some other value instead of h. I would like to use for delta or tau, whatever you can write. Instead of h also we can use some tau. The small changes in the time. So here the time, what is the shift change in the input is equivalent to the same output changes. That's why you can say it is a time invariant system. I would like to give some example. So example for time invariant system. For example, y of t equal to some alpha into the same, you can take it as the previous examples, alpha into x of t. If I like to give the input changes, the input instead of x of t, here I will give the input as x of t plus h. What is your output? Y of t equal to alpha into x of t plus h. That is the input. Now I would like to change the output. Y of t plus h. That is equal to y of t plus h is equal to alpha into x of t plus h. That is a replace t by t plus h. From these two things, this is a 1, this is you can take it as 2. From 1 and 2, y of t equal to y of t plus h. So therefore, the system is time invariant system because both are same. That's why I can say it is a time invariant system. Suppose we need to give some example. If it is not a time invariant system, can you give an example which is not a time invariant system? Y of t equal to t into x of t. This is I like to take it as another example. If I like to change the input, instead of the input x of t, give the shift x of t plus h. The output y of t equal to x of t into x of t plus h. That is a y of t. When the input change, what is the output? I like to take it as equation number 1. Entire input change, y of t plus h. Replace t by t plus h. So t plus h into x of t plus h. So clearly from 1 and 2, y of t not equal to y of t plus h. So therefore, the system is not time invariant system. That is the best example for is a time invariant system or not time invariant system. If satisfies this condition, we can say it is a time invariant system. Not satisfied, it's a time varying system or non-time invariant system. That's why you can say is a when you added the included for linear, so linear time invariant system, that is a LTI system. Hereafter we can use the term LTI, it's a linear time invariant system. Next, what do you mean by causal system? What do you mean by causal? Normally it depends only on the system, it depends only on the past values. That is called a causal system. That is y of t at t is equal to t1, it depends only on the past values of x of t. Then we can say it is a causal system. If it is not satisfy the system, it is non-causal system. In a day-to-day real life, always all the system is a causal system. Rare cases, because only for time shifted only, it is a imaginary cases for here non-causal system. That is a causal system. Next we move on to form stable system. What do you mean by stable? Normally we can say stable is nothing but we know the boundary. Starting and ending we should know. That is a stable for our position like that. That is a stable system. The bounded input have a bounded output. Normally we can say this is a stable system. Bounded input we get a bounded output. A bounded response. Output another name is response. So bounded input, bounded response. That is what you mean by bounded input. Normally we can say the input is x of t. Bounded, go the modulus. That is called bounded. So modulus of x of t, it is a less than or equal to some value, some mu I like to take it as mu or mu x, whatever is some constant. So x of t less than or equal to mu. So bounded input, or simply we can write minus mu less than or equal to x of t less than or equal to mu. So that is a bounded input. The output, that is the output also bounded, that is a y of t also bounded, lies between mu into I, where I is the independent of the input, where I is the independent of the input, or simply you can write some other constant. So bounded input, we can get the bounded output, then we can say it is a bounded, that is a stable system. When the system is stable, the value should be finite value. So bounded input and the bounded output, that's why a system is a stable system. These are the basic things for here. Then a linear system. So system, what is a linear system? What is a time invariant system? What is a causal system? And stable system. So very clear that system is nothing but a functional relationship between the input and output of the system. And linear, it should be satisfy the linear properties. Time invariant, how much shift in the input is the same shift in the output. Causal, it depends only on the past values, past input. Stable, bounded input, we can get the bounded output. These are the systems. And then impulse system, what is the linear impulse response of the linear system? Normally we can say it's a impulse response. We can define y of t equal to integral of minus infinity to plus infinity x of u into delta of t minus u into du. That is the input things. Some impulse function, unit impulse function, normally we can say is a delta of t minus u. So normally delta of t minus u, when t equal to u, the value is 1, all the other cases are 0. So now I can take it as the system response. H of t comma u equal to some function of delta of t minus u, I like to take this. Function of delta, I will take this h of t comma u. So therefore, the output function y of t is, so integral of minus infinity to plus infinity. So now y of t, can take it as input x of t. So integral of, what do you mean by system y of t? Is a function of x of t. That is equal to some function of, the input x of t is here minus infinity to plus infinity, x of u delta of t minus u into du. Once you can take the function is inside, integral of minus infinity to plus infinity x of u f of delta of t minus u into du. That is equal to integral of minus infinity to plus infinity x of u into h of t comma u into du. That is the impulse response of the linear system. It is the impulse response of the linear system, normally we can say. So y of t, integral of minus infinity to plus infinity x of u and h of t comma u into du is a impulse response function. Normally we can call it as h, is a input impulse response function. Input impulse response function. Input impulse response function. Normally we can say like that. What is the relationship between impulse response function So normally we can write y of t can be expressed as the relationship between the input and output relations is y of t can be written as x of t and convolution of h of t. That is the relationship. Output function y of t is x of t, the star indicating for convolution. How it will become? Normally we can write convolution, we know that things x of t, integral of minus infinity to plus infinity, replace one function by u, another function by t minus u. Replace t by u and another one t by t minus u, or y of t equal to integral of minus infinity to plus infinity x of t minus u into h of u into du. So whatever you can write, replace one function by t minus u, another function t by u. That is the things of the relationship with the convolution function. So till we can go through the next class, what we can go for like that, the properties of the convolution, like etc. Properties of the linear time invariant systems. Okay, thank you.